Dear students, welcome to our class on frictional velocity and mixing length. Frictional velocity and mixing length. See, I have defined micrometeorology. Micrometeorology has been defined as the science concerned with detailed examination on the microscale basis of the physical and meteorological factors that are taking place within the ecosphere. So, when we are talking about the ecosphere, in micrometeorological studies of the crop plants or horticulture plants or even for the animals, we should know certain terminology of them. Today we are going to discuss in a very simple way what is the frictional velocity and what is the mixing length. Now, frictional velocity, as I said, several times, we have discussed what is the momentum. Momentum, mass into velocity, momentum. Now, in the momentum, when we are using Newton's law of viscosity, these are the terms that we come across. So, it is very interesting. Let us discuss what is it. Now, the frictional velocity. See, the drag force per unit ground area. Say for example, this is the crop. Okay, this is a crop of 1 hectare, for example. The drag force, when aeroplane is going, this is the flight direction. The drag is in the opposite direction. So similarly, when it is a crop like this, the drag force per unit ground area has the dimensions of force per unit area. So what is force per unit area? MLT square by L square. M by L cube into L square by T square. So what we say in a very simple way is that this is equivalent to the density multiplied by the square of the velocity. The density multiplied by the square of the velocity. In other words, frictional velocity, U star. Generally, in all the micrometeorological studies, or you can say even in the civil engineering also, U star is the word, of course, a term used for frictional velocity, square root of tau by density. Now, so the units are meters per second, where shear stress newtons per meter square. Shear stress is in newtons per meter square. Now, here, to explain you in a very simple way, the density is that of the air in motion. See, for this is a crop. Air is moving. So, density of the air in motion, and the velocity relates to the rate at which the horizontal momentum is transferred to the surface. So, when air is horizontal motion is known as wind. So, horizontal momentum is transferred to the within the crop canvas. That's what, Now, and it is often called as by 3 terms: frictional velocity, shear velocity, or sometimes eddy velocity, etc. Now, see, this particular equation is useful in velocity of a fluid in a flow. Velocity of fluid in a flow. So there it is useful. Similarly, mixing length is very interesting term. What is the mixing length? Usually the term mixing length we use for, say for example, a pocket of fluid is released into this particular horticulture crop. Presume that this is a horticulture crop. A pocket of fluid is there. When the pocket of fluid is entering into this one, for how much time and distance the pocket of air parcel, which has got some molecules, retain its shape, retain its characteristics, retain its velocity. In other words, this is what we call it as the mixing length. Now, the units of mixing length is U, L, du by dz, where fluctuating component in a fluid. Fluctuating component means, it's a hot orchard crop. A fluctuating component is occurring here. Now, a pocket of a parcel has entered with some molecules. Now, what is happening here? L is the mixing length, du by dz is the mean velocity gradient. Now, why? Where this particular term mixing length is used? It is something like a free path. Free path means, in the gas molecules, the distance traveled by a molecule between collisions, so it is very small. Whereas mixing length is thousands times more than the free path of gas molecules. Why and how, I tell you. Say for example, a packet of fluid had entered. That fluid retains its characteristics for some time until it passes through some distance. So that distance we call it as the mixing length. So finally in one or two lines I would like to say that the distance that fluid parcel will keep its original characteristics before dispersing them into surrounding fluid. In other words, mixing length is also by definition the average distance that a small mass of fluid will travel before it exchanges its momentum with another mass of fluid. So this is what I would like to share with you. Thanking you very much. May God bless you.